Live. Hello, everyone. We'll give a minute or two and let people start seeing the stream show up on LinkedIn, show up in other places. I'll go ahead and check real quick
Yep.
too, just to
Just
make sure
checking it.
everything's
Is
going.
checking YouTube.
All right. This is our first show, so we're just making sure everything is going right. Uh, I'll say LinkedIn's interesting too because their video stuff
There we
is a little
go.
bit newer. All right, we're good on YouTube. We're good
Yep,
on
I see it,
Twitch.
dude.
All right, let me look on our LinkedIn. I think we have maybe some LinkedIn folks too that have joined. Let me look at our page real quick. Yeah, it looks like we're live. Awesome. All right, and then I'll have LinkedIn up there too. Hi from LinkedIn. Looks like we got some information from LinkedIn already. Some chat. I'll be
Neat.
watching the chat too, so if anyone has questions or wants to interact, feel free. So I'm looking over here off screen. Let me pause it. All right, now I can interact on LinkedIn too. I think LinkedIn's the only one that's not integrated for chat. Well, welcome everybody. This is our first State of Cloud Native. We're going to start doing some streaming here every week and start talking about some different subjects around Cloud Native. Today I've got Esten on with me. I'm Mike Peterson. All right, you got a hi Esten. You can
Hi.
put up chat if you want to see it, Esten, on the right
Yeah, I
side.
do. It's
Um, so we're gonna talk a little bit about our journey, going all the way back to maybe like the mid 2000s and what we were doing then, and then how we moved from bare metal to virtual machines. I think VMware was the first thing I really touched, vSphere and stuff, and then moving over to OpenStack, and then how we moved from OpenStack to, oh man, Docker's here. Like let's do
yep.
containers, and then moving from just running containers on our workstations, actually getting into orchestration, and oh man, Kubernetes is here now, and like how that happened, how that made things easier. How's it going, Coffee? Nice to see you.
Nice
Thanks
to
for
meet you.
joining us. Um, how that journey was, and like what our experiences were, and then if anyone wants to share some of their experiences, go for it. Right, we're it was a process, and it wasn't super easy. Each step was maybe a little bit more difficult, but things are a little bit different now. Things are difficult in a different way, right? So let me go ahead and get started. We'll have Esten go ahead and go back, take us back to the mid 2000s. And what's your first real technical thing that you're doing? Like, what were you touching for bare metal, and what kind of stuff were you working on?
Oh, let's see here. So we're gonna go back down memory lane. We're gonna go back to high school. Back in high school, my mom was a partner in a law office, and they were little rural law office. Maybe like three or four admin assistants, an accountant, and a couple lawyers that were running in this office. And my first experience in running an IT like organization was setting up their central like Windows small business server, um, little box that was going to run, like, I think it was like PC Law 5.3, Amicus Attorney, and then it was also running their file share and like their Active Directory.
So you're getting
Um,
like email and stuff going there, and then like maybe like the website and like that kind of thing, and it's just a
uh,
single large server for stuff. Or...
no, we didn't do that. We didn't do self-hosted email because that was like more than I was going to run in like my spare time as a high school student, and like it was like my senior year of high school. I was doing this, and so got them, dealt with purchasing all the desktops and getting them all hooked up to Active Directory on the Windows Small Business Server, and getting the making sure that Amicus Attorney and PC Law were set up together and integrating with each other, so that they could sync their workflows up and down back to the server, set up tape backups, and
So what were you just a lot of reading and trying to figure stuff out, looking at manuals and stuff, maybe like doing a little bit of Googling, but
it
maybe a little bit of documentation
it
too.
was
Like
a
that.
lot of trial and error. um, you know, I was smart enough to know what to be ambitious and not admit what I didn't know.
So after that, what you go to college, you stop
Yep.
stop working so much with bare metal machines. You're going to college, you're learning CS, and
Yep.
then your next touch for that kind of stuff would have been virtual machines. So I'll take everyone back to like mid 2000s. I'm working for a startup called webmail.us. We're doing email hosting. It takes us a couple of days to get a new email server running, and it is a script that is so long that no one wants to touch it. We're not using package management. We're not using anything. Um, and eventually we ended up getting bought by Rackspace, and all that stuff got fixed and cleaned up, and we moved to virtual machines. But first thing I'm touching is bare metal for that. It was a nightmare, right? Like if something happened on provisioning one of the new servers, it just took forever. Um, and then let me I'll move up right for one more bare metal thing to 2012. Now I'm working in the government sector.
Hmm.
Uh, and they're doing everything. I'm running a little lab. We've got probably about 3 racks, maybe about 20 or 30 servers, and each one of the servers is running a specific thing. After Active Directory, something's running email, something's running something else. And that's the first time I really touched VMware vSphere, and that was my first actual real work with server work with virtual machines. And what was the easiest thing to do there was just do a migration. So I'm migrating all of these hardware machines onto a single machine, and then like I'm this wizard to everybody. They're like, "Oh man, now we've got all these free servers. What are we gonna do?" I was like, "Well, I can set up OpenStack or something like that." So like that was my first real movement from hardware into virtual machines. And then like I haven't looked back since then. That made it so much easier. I'm like showing the value of, hey, we were using this one server and doing like maybe 5%, 10% utilization. Now we've got a single server that's hitting like 60 to 70 to 80%, and we've got
Hmm.
all this extra stuff for all these other research and projects you want to do. Like, what do you want to do next?
Yeah.
So,
So taking us back a little bit earlier, like after like I graduated, got my computer science degree, I went into digital forensics and spent my, got to, go on site to clients and, collect their data as part of a legal litigation and stuff like that. And, so I got to experience, file servers and capturing virtual machines and capturing laptops and all of that. And then moved on to working at a little independent software vendor where, again, back to a bare metal machine. It's running Active Directory, and I find SQL Server installed right next to Active Directory, which
we have a question. So, what do you suggest for a newbie to get into cloud native, like any paths? Any path. So a lot of the nice thing about now compared to say the mid 2000s when we were really getting into this is that you could do everything on your laptop.
hmm.
Previously, like you needed access to a server if you really wanted to do much. Around 2010 or so, you could run a virtual machine and do a couple of things here and there, but that was still kind of new to everybody. Um, so for you, like you can literally run Kubernetes on your laptop. If you have a virtual machine that's running Linux, you can run Kind, so Kubernetes and Docker. You can do it on Mac, it's a little bit easier on Linux. So you can literally just start by getting either Docker going or Kubernetes in Docker, and then just start reading guides and start deploying things and messing around with the Kubernetes CLI and start like looking just playing
Yeah.
around and like testing and failing and testing and failing and writing your own containers and applications and testing and failing. What about you,
So
Esten? What do you
my
think?
so my, my suggestion on that is if you're looking on to get to cloud native, start by installing Docker Desktop. It's a fabulous tool for starting to get that cloud native journey learning, where you can build containers. It'll install a local distribution of Kubernetes, so you can play with that. And it's a great way to do it if you don't have a lot of hardware. Um, my journey to cloud native started, about I was 2016. I joined a company called Proto Labs, and I joined as a full stack developer. And I then, about a year into it, or about 6 months into it, I joined an effort called Automate All Apps, and we took on automating about 17 different applications that our team supported, and really getting these IIS, like Windows IIS deployments, running and singing. We were very much a Microsoft shop at that point in time. And so then we started a project, to modernize our infrastructure and actually basically rewrite everything from the ground up. 20 years of software knowledge, rewritten from the ground up. And one of the ways we started into that was, trying to get, this was probably about 2017 that this was we were doing this. We I started my cloud native journey trying to get Docker Swarm running on Windows in 2017, which at the time was very much the bleeding edge, and the blood flowed freely.
I say it was a little bit easier for us on Linux, right? Like it just ran. Like I'm still using Docker on Linux and haven't really done it on Mac as much because I just set up VS Code and then just SSH in.
Yeah. Yeah, so like a lot of it was learning. All right, this file system thing doesn't work right on Windows. This networking thing doesn't work on Windows. Oh, Docker Swarm doesn't really work on Windows. Let's talk to the technical leadership and say, hey, if you want this thing to fly, we need to move it to Linux.
That's a fun question, or a fun thing to bring up at a Windows shop too, right? Like,
Oh yeah. It doesn't make any
fun
it
fact.
doesn't make any friends in the IT organization. They're like, why do you need all these Linux servers? I'm like, because I can't do what I want to do on a Windows server.
So when you went to IT, are they running like VMware? Are they managing
Yep.
stuff bare metal? So you're asking just for a couple of VMs to start running
Yeah,
your
so it was
cluster?
yeah, it was initially it's all VMware. It was a vSphere shop very much so. And one of the things that we did is eventually I just started building a bunch of a bunch of VMs. And like one of the big things that you have to think about when you're building VMs and building environments and tying them together is how do you do DNS? How do you make sure that the DNS is consistent and meaningful and useful to the humans? Um,
You're
so that
managing So you're just managing this list of new servers that you're adding all of the time. So you're either using what we're using Microsoft's DNS stuff, or we're
Active
using like
Directory DNS. Yep.
right, yeah, like Bind or something. Yeah, like you're just managing this large list, and every time
Yeah.
a new thing would come up, you're adding another thing to it instead of just like Kubernetes. It just kind of figures it out.
Yeah.
Like,
So then we moved in. So we moved into being more Linux focused, and so then what we ended up doing is we had a small team in our organization that was really focused on Linux server development and using Chef, and so that's where I kind of started really getting more focused into the DevOps tooling and learning how to do infrastructure as code, with Chef. And so we did cookbooks, we did recipes, we did all sorts of stuff. But we were getting to the point where we could automate the creation of Docker Swarm clusters. And yeah, so then along with that came figuring out, all right, how do you do wildcard DNS, how do you do layer 7 routing, to get the traffic from the external load balancer into the Docker Swarm hosts so that they could then route it to the appropriate service on the right port.
so let's go back. So our journey so far for me, mid 2000s, custom script to install a mail server, move up to using package management to install everything, right? Like, and then like by the time you're first starting out with your virtual machines and stuff, are you doing stuff by hand before you get to Chef? Like you're just doing you're copying configuration files to some kind of, maybe you're using SVM
Oh
or something
yeah.
like that to have it stored, or even on your local desktop, or a maybe like a not Confluence then, but like a SharePoint.
Well,
Like
and
you're like
part of
using configuration.
Yeah, and part of the reason why, like at the time that we were doing that whole migration to a new platform, was that the goal of the Automate All Apps project was to be able to reproduce an environment. And like what we found is we had too many like bespoke configurations that between the environments, that replicating an environment was not possible at that time. Um,
You're just
and
like close enough. As long as you get it close enough and stuff looked about the same, you were good.
Yeah, and so there's a lot of hand tuning of servers, a lot of hand tuning of configurations, dropping passwords and by hand. No,
A lot of
no,
diffs.
yeah, no real not no real good automated management for secrets and stuff like that. And so kind of we moved into more of a where our servers were no longer pets; they became cattle. And so like that was kind of our first stage in moving to our cloud native journey, was um, getting from the point where you care about your virtual machines or your bare metal servers as pets that you care and feed and maintain, to um, turning your servers into cattle that if they misbehave, you're turning them into hamburger immediately and spinning up another one.
Another question: do you think there's any risk to cloud technology by other emerging technologies like satellite clouds? You're talking about like I think on-prem type stuff, or like edge type stuff. I think people need both, right? Like I
Yep.
think that everyone's kind of needs both. So I wouldn't necessarily say it's a risk. I think it's going to be a split. Like maybe it's expensive to run stuff on-prem too, or even at the edge. So you're going to offset some of that with cloud resources when you need it. It's harder to maybe buy a piece of hardware and throw it in. compared to like being able to just kind of scale up on the cloud. So it's kind of a mix of both. What do you think, Essen?
Yeah, I mean, so the previous organization I worked at, Protolabs, is very much an on-prem shop for the most part. Like all of our compute was on-prem, um, and there's a trade-off that you make, choosing on-prem versus cloud, or choosing hybrid cloud. If you're doing a strictly on-prem, you get a lot of control, and you over monthly spend of cost, because it's more of a capex investment, instead of an OpEx investment. And so, like, your operational expenses are fairly fixed, but you're also looking at a fixed scale. So, like, if you need to burst beyond, what you end up doing in an on-prem environment is you end up spending, for your peak capacity, regardless of whether or not you're going to use that peak capacity. Whereas in the cloud, on the other side, you spend, it's more of an operational expense. You're not investing in the capital to rack and stack your machines, but you are paying for leasing what compute you use. And so it's an on-demand model, so you can burst, really quickly, but you also need to take the responsibility and do the automation to scale down when you don't need that burst capacity, to minimize costs. So you can get AWS bills that are 60, 70, 80, 100, 90, 100K a month, very quickly, if you start operating at any like type of scale. And you can basically bleed yourself out in cloud costs. um,
Say some of the expense too, it's not necessarily just the cost of the server, it's the time it takes to figure out configurations, to figure out how much heat you can have if you've got like a small lab or something like that. Like it's all these calculations you have to do, and then you place an order, and then it may take like a month or 2 months for that to even get to you because they have to configure the server, especially if you're using like a small shop that's doing custom super micro
mhm.
configurations. Like it's all this time it takes, and then that could be lost opportunity for you to actually like create something in that time. So yeah, the trade off is like there's so many things that go into the trade off, right? Like it also doesn't feel good to rely on the cloud for everything. It's nice to be able to play around after you've already purchased a server and have it on prem to do different things and try different things on it. Especially since you control more things like the network and stuff like that without having to pay extra to have that control.
I mean, but the other thing too you got to think about there is that, does your organization have the, intellectual, power in their personnel to operate a data center? And how, can they design the network? Can they is that within your company's wheelhouse? Because, there's a certain level of flexibility in not having to invest in that knowledge base, by using cloud technologies that you get with using, say, like AWS or Azure or GCP, or name your favorite cloud provider here. Um, uh, but, like, again, it's that trade-off. You're going to pay a premium for, your compute cost, because you don't have to commit to it in advance. Um, you can get a discount if you do commit in advance. But, if the management of on-prem infrastructure is not in your company's wheelhouse, there is a cost to, basically learning those skills and bringing those skills to bear, in an effective manner.
I'll say I firsthand experienced that. I was working for a government contractor in around 2012 to 2014, and in that time frame, I set up OpenStack for him. I did a lot of learning. I did a lot of posting to our wiki about how to fix it and how to do it. But then when I moved on in 2014 over to a OpenStack company, they tried to upgrade the cluster, and within like a week or two of me leaving, I see on the OpenStack list, hey, how do I get Keystone connected back to Active Directory? I can't figure this out. Even though I had the search and stuff and everything set up for it, stuff had changed just enough that basically what they had running in production, it was gone within like a couple of weeks, right? Like so they had to start over from scratch and figure out, hey, can we even support OpenStack anymore? Do we have to go back to like using vSphere or something like that, or vCenter to make this easier for us, right? Like it's that fear too, because if you don't have enough people, Kubernetes is very similar too, right? Like there's not as many Kubernetes engineers out there as there might be like vSphere, so it's scary, right? But there's also all these other companies coming up that can help you with that and like be your platform team and help out. So
Mhm.
there's also the benefit of that. All right, so let's let's move on to, let's see. That was a great question, right? Like,
Yeah.
um, what do we move on to now? That sidelined
Well,
me for a second. Let me think.
I kind of want to maybe do on a little bit of a tangent to that. So like one of
Okay,
the
yeah.
thing, so one of the things like that I do a lot in my free time is my work is my hobby. I do like I literally call this work creation. um, and I have a home lab. You know, like one of the things that I like to build and figure out is like how can I build a better, you know, cloud native system? Like how can I leverage these or the newer orchestration technologies and deployment technologies that are coming out, like things like Argo CD. Like how do I get it to the point where like I can provision my images quickly? So at home, I have a rack. I've got a 22U rack that's sitting just on the other side of that bar behind me. Um, I can hear it right now. It's got 4 Dell R610 rack servers that I bought off eBay. You know, each has 192 gigs of RAM and dual hexa-core Xeons that are hyper-threaded. And one of them's my file server with like I think it's got like 30 terabytes of disks total, and you know across a 24 disk shelf and like a 6 disk array inside the server itself. And you know it's all structured in TrueNAS and stuff like that. But it operates as basically my NAS, so that I can use things like NFS for storage and provisioning of like my Kubernetes storage drivers, and using my persistent volume claims and stuff like that. But you know, I deal with everything from the hardware up. So I'm responsible for the virtualization environment. I happen to use Proxmox. It's nice. It's free. It's featured enough that I can and easy enough to automate against. I use tools like Packer to build um, custom VM template images so that I can basically um, build that template and install all of the updates. So when I create new stuff, I've got it all up to date, so I don't have to go update it before I install Kubernetes on it. So, and I use HashiCorp's Packer tool to manage that automation with a combination of Ansible and other scripts like that. So kind of building up that bottom layer of my on-prem stacks where like, okay, now I can use Ansible to provision a cluster. So I can say I need 6 nodes with this image type, and then I'm going to apply these Ansible roles to these 3 nodes and those 3 nodes, and now I've got and then I can deploy connect them up to my PF9 cluster and have it provision Kubernetes for me, right?
That's a pretty good setup. I guess that's it. Also, like now, like you're saying, how do I get into cloud native? Things are cheaper now too than when
Mm-hmm.
it was like 2005, 2010. Like you've got all these secondhand servers and stuff that you can buy if you want to set up a lab at home, where it's not going to cost you what it would cost like an enterprise to get into it. Like they're going to be buying the latest and greatest more than likely. You can go buy something that's like maybe 1 or 2 gens back, and then start messing around and learning how to actually deploy a Kubernetes cluster locally. Like
It's still
before,
going to cost you $100 to $150 a month in electric
oh yeah, that
to
gets
run
cost you
it.
too. But it'll warm your basement if you
Yeah,
need it.
it's a little
You're
space
looking at
heater.
underground servers or something like that. That'll be helpful. All right, so we've gone to Docker Swarm. Now, when did you make the jump from Docker Swarm to Kubernetes, and what was
So
that? What was that journey like?
so it was about a year before I decided to leave Protolabs. I had known that we were going to have to move to Kubernetes probably about 2 years before I started the initial research and building out Kubernetes. And so, along with that build out, so when we had built our product up initially, we made trade off decisions in favor of getting things up to speed faster. Like trade off decisions on like how we configured the operating system, trade off decisions on how we configure firewalls, trade off decisions on how we structured the network for a NIST compliance and stuff like that. And so like as you are building out an on-prem cloud native infrastructure, these are the types of things you have to think about. Like what type of security frameworks do you need to be compliant for? What kind of tooling can you use to validate that you are meeting those compliance requirements? and how can you build as much of that into your base image so that you don't have to worry about it when it comes time to provision new servers. So that's where I started, and then once I got a base image that was
And you
Ubuntu.
take rel images that have SE Linux enforcing on and turn it off so that you don't have to worry about security. You actually
No, I actually went with Ubuntu 2004 because we were in that CentOS 7
have on
debacle
or
where
off. You didn't.
or yeah, it's like oh, CentOS 8 is now end of life and you're moving to CentOS Stream and I can't no. No, I'm not going to do this. So we were moving to Ubuntu 2004 at the time, and we ended up I ended up getting them an automation suite set up that I could make my servers, I think, within like 28 high and medium findings or so, plus or minus, of having the Ubuntu CIS level 2 uh, standard for securing the machine. So that included host-based firewalls that locked down anything that wasn't explicitly opened, and removing any services that weren't explicitly needed. All of
Just
that.
extra protection beyond like your network team, like what they're doing on the their
Yeah,
firewalls.
basically, I was designing my servers to be islands. I didn't want to trust the network. I didn't want to trust the anything that I couldn't control. So I was basically trying to make my servers as hardened as possible so that I could do defense in depth. And then once I got that started, I started trying to figure out, all right, how do I build an on-prem Kubernetes cluster? So we had some security concerns that we had to take into account, both from a government regulation standpoint and from like a PCI compliance standpoint. And so one of the things I was starting to look for was Kubernetes distributions that took a more security forward stance. So we ended up implementing Rancher's RKE2, just because it was the easiest one to achieve the Kubernetes CIS compliance standard. And so they had a guide for how to get to that full compliance on that. And so ended up figuring out how to spin that up automatically, designing it with an HA proxy load balancer in front of it to do the external load balancing across all the nodes, so that I could use ingress and have traffic routed to the nodes and basically expand the network as I needed, and also making sure that those load balancers were set up in an HA pair so that if one happened to go down or I needed to do maintenance on one, I could take one down and have the virtual IP automatically flip over to the other one. But yeah, kind of taking that, figuring out how to get the and actually before I even started reaching out to RKE2, I started out with playing around with kubeadm, trying to figure out how do I provision a Kubernetes cluster using kubeadm, and then I'm like no, this is a bad idea.
What do you think this is? This is 2020, 2019?
This is about 2020-ish.
2020.
Yeah, no, 2020-ish is about when I starting to do this, and
Why did
this is
you
as
swarm to Kubernetes? Was it just because like that seemed like where everyone was going, or
we were actually hitting real limits on the maximum number of nodes we could put in a single Docker network. So we were hitting that. Docker Swarm's software-defined networking has virtual networks that basically are limited, are configured in a /24, and we were getting to the point where we had containers. We had the number of replicas that we were running was getting to the point where we were running into real IP limits on a /24, and
that's a lot? So, anyone have any other questions or comments, or I'm sure that most of the journeys people have made so far to Kubernetes are probably pretty similar, right? Like you start out, if you start in the mid 2000s or so, you're starting out with bare metal. You're moving to virtual machines, so you're probably learning how to do vSphere and vCenter. After that, maybe you use OpenStack, or maybe you use AWS or something like that, and you learn the whole cloud init model. and cloud images and how to deploy with that. And then after that, maybe containers. Okay, I will say
Mm.
this. Okay, so the movement from virtual machines to containers when supporting developers was amazing,
Oh
right?
yeah.
So not only did I have to stop caring which version of an OS I was using for the virtual machine because they wanted specific version of MySQL or something else, I could just be like, all right, go set up your image for it, and you can do whatever you want, and I don't have to manage which packages you're using. I don't have to worry about if I'm using CentOS or Ubuntu. Like I moved originally, I installed
Mm.
OpenStack on CentOS, and I was giving everyone CentOS virtual machines and stuff. But then I realized very quickly that the Java developers I was supporting, they wanted the latest and greatest everything, and I
Yep.
couldn't easily do that even with like the rel additional packages. So I moved to Ubuntu, and that made it a little bit easier. But then
Yeah.
teaching the developers to deploy a virtual machine on OpenStack was still not the greatest experience, right? I would have something like a developer would launch a VM and then try to cancel it real quick and then ask me why it wasn't working or something like that. Or just issue all these commands. But like even just giving someone a full virtual machine, that might be too much. Like, but if I can just give them a container or some way to containerize their code and they can just deploy it to where I'm not worrying about Tomcat or like if their jar is getting placed in there and I'm just deploying their containers that they wrote and worked on their local machine, it made my day so much easier in infrastructure.
That is one of the big things that you get out of the moving to a containerized deployment model is that the artifact that gets created is versioned if you do it right. So if you set up your continuous delivery pipeline such that they're building it and they're tagging it with a build number or a commit number, you can get it to the point where you know for sure what artifact went out is the one that the artifact you wanted to deploy is the artifact you want to deploy, and you've got some guarantees around that. The other nice thing about it is that it's a universal package, right? It's not it's no there's no question about did you install these dependencies. There's no question about did you toggle this config file. You're like no, I deployed your image.
It was working on my machine, and then you're like, which version of Tomcat are you using? Does that matter? Like what
Yeah.
version?
There's another benefit to it as well. Especially if you start especially if you start scaling teams. Like when I was working as the principal DevOps engineer for Proto Labs, one of the we had our platform operations team, which I was the lead on, and then we had our platform engineering team, which was designed to developing like the developer focused like tooling, like things like what providing them a common logging abstraction, a common metrics abstraction, a common tracing abstraction. And one of the things that we did in conjunction with them is built a set of base images that we pre-configured with all of the packages we needed for hooking up to things like New Relic or Datadog, things for like configuration settings for the .NET framework or Java or like common enterprise level configurations that we as an operations team and a platform team all decided that these shall be the configs. Thou shalt not change them.
So also like if you go back to say like OpenStack and stuff too, and even like the Docker Swarm, like you start with OpenStack, I started running into like for most customers, we ran into issues with either Neutron or RabbitMQ. So as we scaled up, networking started failing because the amount of network information I had to keep was getting too large, and then RabbitMQ would start failing because the queues were getting too big and too much traffic was needed, right?
Mm-hmm.
So it was difficult to scale VMs. As you move to containers, you can start scaling a lot easier, but the complexity moves, right? Like it's not
Mm-hmm.
necessarily complexity around networking and stuff. It's around other things like how do I create more worker nodes fast enough to scale, and then how do I remove those worker nodes if I need to scale back down? So do you have any insights into the scale and the complexity, like how the complexity's moved and where it's moved more to
So
ingress? Or...
I mean, the biggest part of it is you is that you have to think about the system holistically when you're moving to a containerized world and moving to a cloud native ecosystem. Like as a platform operator, you have to start thinking about, all right, what tooling are we going to use for ingress, like, and then get everyone to use the same tooling, right? And so that way you don't have to worry about like, okay, I'm gonna, this person's gonna use Istio, this person's gonna use Nginx Ingress, this person's using HA proxy. Like, no, take that away from the developers as a decision entirely. You
Well,
give them the ingress layer, and then you say use this resource.
it's how to use it because like the everything around the ecosystem is like changing so fast too, and something comes out and everyone's like, I want to try this brand new thing, but you haven't had a chance to actually work on it or use it. So it's yeah, it's like you can't have 100 developers using a different ingress setup, right? Like and then
Right.
like if
Well, and so like one of the things that you get is like, okay, we don't want everyone using different logging packages. We don't want everyone using different metrics packages. We don't want everyone using different messaging paradigms, because because then we can't scale them or know how they work. So like like one of the reasons we moved away from RabbitMQ as a messaging solution was that, one, we didn't have people on the operations team who knew how to operate it well enough and scale it and man it and keep it healthy. And two, there were other tools that and distribution things that we just couldn't do. So we decided that rather than trying to operate our own messaging solution, we farmed it up to Azure and used Azure Meshes Bus. And it was one of those things where it was like, we got a tremendous increase in reliability. We got a tremendous increase in capability, and we didn't have to manage then operate it to keep a certain level of nines that everyone would be happy with.
that's perfect. Yeah, like so when did here's a question, I guess. When did you move from the idea of your in infrastructure and operations to, oh, I need to build a platform so that people can just use it, right? Like that's the big change too, is you went from I'm just a systems administrator, oh, I'm just a systems engineer, oh, I do the computer part or I do the server part and then the networking team handles this other part. So you've gone from being singular in what you work on to having to be a full platform and offering to somebody that they don't have to make those decisions.
I'm a DevOps engineer, and basically the way I describe my job is that I need to be a mile deep and a mile wide. Um, I need to have an understanding at the application level so that I can converse with developers and figuring what it is that they actually need, and then be able to take those needs across multiple teams and say, all right, here's the common subset across 80-90% of them, right? How can I take that out of their day-to-day concerns and raise it up to a platform level so that I can operate it at scale, right?
How large
And
would you
that
say your platform team was in your previous role?
in the heyday, it was about 10 people. And that was just the operations side of it. And the engineering side of it had probably another 6 people on top of that who were focused on building like actual like native packages that would be that would be our team's contract to the developers, right? And that's one of those things that's where as you start thinking about your cloud native journey, it's not just a, oh, here's Kubernetes. Let's just throw Kubernetes out there. Oh, here's a Helm chart. Let's throw this Helm chart out there. Oh, uh, why isn't this working together? It's because you didn't think about it as a holistic system. Like it's like, you know, how do you make it so that how do you make it so that developers can go faster? You start thinking about, how do I remove concerns from the developers so that they can focus on business logic?
How easy was it to find a new member and get them up to speed on the platform team after you've made these decisions? And like the background has to be something related to like maybe they knew how to do it before Kubernetes came along, right? Like or like could
Our
you just take a Linux engineer and be like, hey, can you just take over this, or did they have to have some kind of background, right?
I mean, our onboarding, once we found someone that we wanted to, it was about 6 to 8 months. Um,
And then in that same time, was it common to like lose somebody too to like some other new like startup or like some new exciting thing after they learned how to do it?
it's difficult to keep people. There's always that retention problem, because like the problem with the DevOps engineer is that we are a scarce breed of resource. It's like it's hard to find someone who's got that developer mindset, who's comfortable understanding all of the pieces in the stack and on the operations side, and being able to tie them together in a way that's meaningful and can deliver business value. It's there's not a lot of people who have that breadth and depth of experience to go and do that on a regular basis. And I mean, it's one of those things where it's just like you just got to keep experimenting. I mean, I've gotten my my master's in software engineering. I have a graduate certificate in computer security and embedded systems, and then you top off going and getting my CKA, certified Kubernetes administrator certification. I'm pursuing my certified Kubernetes security specialist cert. I'm pursuing my certified Kubernetes application developer cert. um, you are not done learning. Like if you choose to take the path of the DevOps engineer, it is a path of continuous and unending study, because something new is always coming out.
Say back in the day, if someone asked me how do I get into this, I'm like, oh, go get your CCNA and go get your RHC, right? Or get your RHCTA or whatever, like the original ones. Like go get that, and then you'll be set, because that'll teach you everything you need to know. Now it's so much more than that, because you could tell someone go get your RHCE, right? Like you want to do Linux, go get your RCE. If you want to do networking, go get your CCNA. But at some point around 2010 or early 2000s, like you need both of these, because you can't just concentrate on the servers anymore. You need to know how the network works. You need to understand that to be able to actually create like OpenStack. You can't just know how a single server works. I need to know how the networking works, because I got to configure that, right? Like I got to tell the networking engineers what I need on their side, and then I still have to configure it so that these servers can talk to each other. So you're talking about moving from single servers to distributed systems. The complexity goes up. Now, I'm not saying this to dishearten anyone from learning it. Definitely dive into DevOps, start learning everything.
Yeah,
If you like to learn things, go into it, right? But for the practitioner, go learn it, because it's high demand and it's awesome and it's interesting, and you're always going to be learning new things. And for the people hiring those people, it takes a little while to get them up to speed, right? Like it's going to take an investment to get there.
it
It's worth
does.
it, especially if you get someone who can champion things. But then you always got to move. You got to worry about like the next biggest and greatest thing. So
Well, and the way I
and it
look at
comes
it,
along with that mindset, right? Like you're always learning,
yeah,
so you always want to do something new. And if someone stops doing something new and innovating, then you might want to move on, right? Like,
right. I mean, there's always that risk. And but on the flip side too is like Kubernetes is not a panacea. Um, if if you're in an organization that can't manage the complexity of Kubernetes, find a provider that can manage the complexity of Kubernetes for you. Because it's at 3 releases a year, and it is not a small endeavor to take on.
but that can also buy you time to where you can
Hmm.
start working on it while someone's getting up to speed, while you have
Right.
more people getting up to speed and they're sharing knowledge and learning, and then your developers can at least have something that they're already kind of getting used to and using. So yeah, all kinds of I don't know, interesting stuff out there to learn around it. Let me think. What can we go on to next? So you've gone to cloud native basically. What is your day gone from managing virtual machines and setting up maybe Nginx and Nginx configurations to managing Kubernetes and setting up ingress and stuff like that? Like it removes the complexity from being on a single server, but now you're focused on so many more things than just like a singular. Oh, I'm the
Yeah.
Apache or I'm the Nginx administrator that does everything. Now, like that stuff's taken care of. Like I
Yeah.
can get a start with Let's Encrypt, no problem. Like is load balancing and that kind of stuff taken care of. So like, what do
Yeah.
you worry about now?
So right now, I worry. What I worry about is how do I keep all of those components up to date, right? Vulnerabilities will come out and every day. New packages will come up. How do I get to the point where I can deploy new versions of my software quickly, reliably, and uh, when I need them to roll out, and then test to make sure that my end-to-end stack is still operational and meeting all of the contracts that I laid out to my developers that I said I would meet.
Well, awesome. I think we're coming to time. So let me give some information. So I'll say if you want to talk to us, join Slack. So here's our Slack information. The channel that's associated with I'll flash this back in a minute. The channel that's associated with this stream, we're doing it every week, is going to be State of Cloud Native. And if you want to get in contact with me, you can either post on LinkedIn or you can hop in there, and I'm at Peterson. So let me put the join with Slack while we join us on Slack while we finish this up. But yeah, definitely reach out. Like reach out to us. We'll set you up with one of our wizards that can help answer your questions or help give you some guidance or show you what our platform is about and how we can demo things and make Kubernetes a little bit easier and maybe expand on your platform team. Let's see. Let's think. What else do we want to talk about? So now you're a Kubernetes wizard. You're always managing stuff. Everything, the complexity's moved out of it. What's the next interesting thing you're looking at? Is it Argo? Is it like
So
what's your excitement around?
so like my research area that I really like to spend time in is like how do I build my platform for my home lab better, right? So right now, what I'm currently digging into is how can I leverage Argo CD to deliver a standardized platform for my Kubernetes clusters so that I can just spin up a cluster and then have it and then deploy one Argo app and have everything that I need, I mean, one or two Argo apps and have everything I need to have an operational Kubernetes cluster. But along with that, what I'm looking at is, all right, how do I spin that cluster? How do I spin that initial management cluster up in my environment? So like, how do I get my initial Kubernetes cluster? Because you always have a chicken and the egg scenario if you're trying to build a platform in your home lab. It's like, what do you need first to produce the other things? And so like you're trying to figure out like, how do I get that initial seed so then I can use that initial seed to provision everything else. So I'm thinking about like, how do I provision Argo CD on a central management cluster? How do I provision Cortex on a central management cluster? And then tie in all the different Prometheus instances on all my different clusters into Cortex, so I get a centralized single pane of glass view of all of my clusters. How do I spin up centralized logging? Like, so I'm probably going to end up looking at either an EFK stack or a Grafana stack, a Grafana Loki stack, so that I can do centralized logging in my environment, and then have all of that feed up to my stuff. And then like once I get those like core management pieces set up in my lab, all right, now I've got my management cluster. How do I then set up my clusters downstream that will have like what ingress provider am I going to use, what secrets provider am I going to use, how do I deliver those initial secrets so that I can initialize the secrets provider in a secure manner and utilizing GitOps. um,
And
you know there
reminder, this is just thinking about your home lab. This isn't thinking even about like the enterprise running stuff, right?
yeah, so this is like, and then like, how do I get my home lab hooked up with SSOs? Like, I have my own personal jump cloud account for having an LDAP solution, and like, how do I set that up so that I can use my LDAP through jump cloud to sign into all of these services and manage them with single sign-on.
Awesome. Thank you so much for your time, Esten. Thank you so much for everyone else's time too that joined. I hope someone or everyone got something out of this. And like I said, if you want to reach out to us, we can hook you up with someone to talk about your journey and what you're trying to do, and see if we can help out. Join us, but join us again next week. We'll have some more topics to talk about. We're going to be on here Fridays at 11. Interact with us on LinkedIn, reach out on Slack, comment on YouTube or Twitch, and we'll be happy to talk to you. All right, Esten. Thanks everybody.